Hello, my name is Daniel Mars, and the topic that I will be presenting is Gibbs free energy. Laws of thermodynamics. The first law is energy is not created or destroyed. It only changes form. For example, potential to kinetic, kinetic to heat. The second law is that the entropy of the universe is always increasing. Entropy is disorder. Entropy is always increasing. The third law is a perfect crystalline solid at absolute zero has an entropy of zero. Entropy. Entropy is measured by joules per Kelvin. Entropy is a measure of disorder of a system. The value of it depends on the mass of the system, and it can be positive or negative. The increase of entropy is favored. Some examples of increased entropy is spilling a jar of marbles on the floor, shuffling two decks of cards into each other, boiling water, or making popcorn. Entropy can decrease. The entropy can only be decreased when it has increased somewhere else. The entropy decreases when it interacts with something else that the entropy increased with. Examples of decreasing entropy. If you have a hot cup of coffee, you cover it with a plate, and you leave it, it cools. Another example is an air conditioning that cools a room. And another example is a refrigerator. Gibbs free energy. Gibbs free energy tells us about the spontaneity of a process. The change is in the equation delta G is equal to delta H minus T delta S. If delta G is negative, then it must be spontaneous. If delta G is positive, then it must be non-spontaneous. Going along with the equation, delta G is equal to delta H minus T delta S. When it is energetically favorable and entropically favorable, it will always be spontaneous. When it is energetically unfavorable and entropically unfavorable, it will never be spontaneous. When it is energetically unfavorable and entropically favorable, it will be spontaneous at a high temperature. When it is energetically favorable and entropically unfavorable, it will be spontaneous at a low temperature. Spontaneous processes. A spontaneous process occurs without the addition of an external energy. It could be quick or it could be slow. It does not relate with reaction rate. Spontaneous processes can either be exothermic or endothermic. Spontaneous processes must increase the entropy in the universe. Spontaneous. Delta G determines if something is spontaneous or not. Another thing that tells us is a sign. It releases free energy and it moves to a lower state. The direction of spontaneous change is the direction where the entropy changes. So, a problem with the Gibbs free energy equation, delta H is 119 kilojoules, delta S is 254.8 joules per Kelvin, and temperature is 25 degrees Celsius. So there's two things you have to do. One is convert this to kilojoules instead of joules, and you do that by dividing by 1,000. So you move the decimal places 3 times, and it would be 0.3548 kilojoules per Kelvin. Then to convert this into Kelvin, to do that you have to add by 273 and you get 298 Kelvin. Then all you do is plug it in. So it would be delta G, which is what we're trying to look for, by delta H, which is 119 kilojoules, parentheses, minus 298 Kelvin times 0.3548 kilojoules per Kelvin. So Kelvin cancel out. So when you multiply, it will just be kilojoules that we bring down. So it'll be 105.7 kilojoules. Bring down the 119 kilojoules. And then you subtract, you get 13.3 kilojoules. You round that up, you get 13 kilojoules, right? And since this is delta G, since it is greater than 0, then the reaction is non-spontaneous. That is all I have for my presentation. Thank you for listening, and bye.